Hey, let's talk about OpenShift. OpenShift is one of the most popular Kubernetes distributions in the world. It exists since almost 10 years and went through 4 major version releases. Already back in 2011, OpenShift was based on containers, but Red Hat developed their own custom container technology and container orchestration tools. It all changed with the release of OpenShift 3 back in 2015. With this release, Red Hat completely changed every technology underneath OpenShift. It went from custom developed services to fully embracing the Kubernetes. At that moment, OpenShift re-emerged as one of the first full-featured platform-as-a-service systems built on top of Kubernetes. Many features of Kubernetes that you love and use, like deployments or role-based access control, initially appeared in OpenShift and were later merged or adopted upstream to become the core of our favorite container orchestration tool. In 2019, OpenShift jumped further into the bright container future with the release of version 4. I was lucky to be one of the first production users of OpenShift 4, architecting and implementing multiple clusters for one of my clients. I was amazed by some of the new features that OpenShift 4 brought. The only problem was that Red Hat didn't release the open source edition of OpenShift 4 till the middle of 2020. If you don't know, almost every Red Hat product has the enterprise and the open source editions. There is an enterprise satellite and there is an open source format, for example. And there is an enterprise OpenShift and an open source OKD, the community distribution of Kubernetes. Don't ask me how community distribution of Kubernetes abbreviates to OKD. Naming is very strange these days. You can think of an open source edition as the upstream and the enterprise edition as the most stable, tested release that costs money in return for Red Hat support, Red Hat branding, and sometimes slightly different features. In case of the OpenShift 4, this model got reversed. For over 1 year, Enterprise OpenShift was a cutting-edge, state-of-the-art technology, while OKD was package version 3. But now, things finally changed back to normal. I thought that with the release of OKD4, it is a great time to show you all the good things that are happening in OpenShift and also demonstrate how OpenShift differs from Kubernetes these days. Because OpenShift is a big and complex technology, I won't be able to show everything in one video. That means you're going to see a whole series of videos on different cool technologies and concepts of OpenShift and Kubernetes. Even though I will mostly show OpenShift, remember that OKD is an open source tool and this tool consists of many open source technologies. Chances are that many of the things you are going to see will either make it into the Kubernetes core or will somehow reappear in a different form in the Kubernetes community. In this video, I will show you how to install the new OpenShift cluster on the AWS. I will keep saying OpenShift in this video because it's a bit easier to pronounce and you can roughly put the equal sign between OpenShift and OKD. One of the biggest changes since version 3 is the installation process. Instead of using Ansible, there is now a dedicated OpenShift Installer tool that takes care of the complete cluster installation and does it in only a few command line prompts. It's a bit similar to Kubernetes Kops if you ever used it before. I've already installed it beforehand. It's just a single binary that you need to drop to one of your past directories. Let me run the OpenShift install create cluster command. First, I need to choose the SSH key so that I can later log into the cluster if I really have to. I can also decide to skip this step. Then I need to select the platform. OpenShift Installer works with all the major cloud providers as well as private virtualization solutions like VMware or Ovirt. Under the hood, this installer is using Terraform to provision the infrastructure. It uses Terraform as an internal library, meaning that you don't have to actually install Terraform on your local machine. This installation is called Installer Provided Infrastructure, which means that the OpenShift installer will not only install the OpenShift cluster, but will also configure the complete underlying infrastructure. There is also a user-provided infrastructure option, in which you have to prepare all the infrastructure and then installer will make an OpenShift cluster out of it. This option is especially useful for bare metal clusters. I'm going to use AWS so that we can also see how this installer natively integrates with various cloud services. Then I need to choose the base domain. Installer pulls all the existing hosted zones from my AWS account and lets me select one. I've pre-created this hosted zone before making this video. Next step is to choose the cluster name. After that, I need to set the pull secret, which could be either a real secret to access your registry or a fake string from the documentation. Now I can finally trigger the cluster installation. It will take around 30 minutes. Already at the installation stage, we can see how different OpenShift 4 cluster management is if you compare it with version 3. We only had to configure a handful of options, and what we are going to get in the end is the complete platform as a service, tailored to the particular cloud provider. Let me time travel to the end of the installation. It took the installer almost 35 minutes to install the complete cluster. It might sound like a lot, but once you'll see what exactly was installed and configured during this process, you might think it's actually pretty fast. When finished, OpenShift Installer gives us the password for the default kubeadmin user. With these initial credentials, we can further configure the cluster, but I won't go too deep into the cluster configuration in this video. There are many things that you can adjust to your needs, and such topic requires a dedicated video. Tell me in the comments section below if you want to learn more about it. Let's check the AWS Console to see what exactly the installer did for us on the infrastructure side. I'm first going to check the running EC2 instances. We can see here 6 new instances, 3 for the control plane and 3 for the worker nodes. There are dedicated IAM roles created for masters and workers. We will see them in a bit. OKD is based on fedoracoreos and is the default operating system for every cluster node. There is a separate video about fedoracoreos on the channel. Check it out to learn how it's different from your regular operating system. There are also security groups with all the required rules in place. If you think that the description of the security group's rules could be a bit nicer, then I'm with you. Let's check the load balancers. There are 3 of them, 2 external ones and 1 internal. One of the external ones, for example, makes the OpenShift API available to you over the internet. Let's now check the IAM roles. Master role has lots of permissions to manage the storage, the load balancer, and the security groups. Worker role doesn't have anything too specific inside. Now let's jump to the Route 53. There is a new private zone for our cluster's base domain. Inside of the zone, OpenShift Installer pre-created many different records so that we can resolve the API and the applications running on the cluster. Talking about applications, let's check the third load balancer created by the installer. For whatever reason, this 4.4 release of the OKD uses the classic ELB. And this load balancer is the one that gets traffic from the outside to applications running in the cluster. Finally, let's check the VPC. There is a new VPC just for the cluster with the new subnets, 3 public ones and 3 private ones, 1 per connectivity type and per availability zone. There are also 3 NAT gateways, once again per each availability zone. As we just saw, the OpenShift installer provisioned many different AWS resources by following the best practices in terms of security and availability. You can also provide the installer with the config file to further customize the installation to fit your particular environment. Before we wrap up, let me show you some of the files that installer has created on my laptop. First of all, let's check the metadata file. Here we can see the cluster name and the unique cluster identifier. There is also a Terraform state file. Keep in mind that the installer uses Terraform internally, but despite this fact, you won't be able to use Terraform directly because the installer does not generate any Terraform templates. Still, you should probably save the state file to a Git repository. There is a destroy cluster command that will need the state to properly clean up everything. There is also a default kubecon file that you can use to perform the initial cluster configuration. You probably don't want to use it after you finish with the post-configuration activities. And that's it for this video. As you just saw, the new OpenShift installer is very easy to use. It creates a whole bunch of cloud infrastructure resources, and it does it by following the best practices of the cloud providers that it supports. Of course, every organization has different conventions and approaches to managing the cloud infrastructure. The default setup that OpenShift Installer provides might not be enough. Luckily, there are different ways to further customize the installation if you need to do it. One problem with this installer is that it works outside of your organization's infrastructure automation. If you use CloudFormation or Terraform to describe your complete infrastructure, then you might not like the idea of another tool generating thousands of different cloud resources outside your primary infrastructure as codebase. In the next video, we will see a few technologies that lay at the core of the OpenShift cluster and that make the cluster management and operations a breath of fresh air. If you or your company are interested in OpenShift or Kubernetes consulting and training, you can contact us via the email address provided in the description. Don't forget to subscribe to our channel and press the like button. Thanks for watching.